Welcome to The Explainer. So today we're taking a pretty mind-bending journey into the deep future of our universe. We usually think of space as this endless, unchanging canvas of stars and galaxies that's just going to be there forever, right? But what if I told you the universe is actually actively hiding its history from us? Get ready for this, because the cosmos as we know it, it's quietly disappearing. Okay, brace yourself for this staggering reality. 94% of the universe's galaxies are already gone. And no, they haven't been destroyed in some giant cataclysmic explosion. Instead, they are permanently beyond our reach. They're trapped behind this insurmountable wall of time and distance. Literally, even if humanity could somehow build a spaceship that travels at the absolute speed of light, we can never, ever reach them. They are lost to us forever. Which brings us to a really profound realization, perfectly captured by astrophysicists Lawrence Krauss and Robert Schreier. Just think about how unbelievably lucky we are. We live in this highly privileged, exact right moment in time where the evidence of the Big Bang is actually still visible to our telescopes. This is our loneliness hook. Basically, if we wait too long, the universe is going to look completely different, and its origins will be absolutely unprovable. Okay, let's dive right into this cosmic detective story. We've broken it down into 5 parts. First, a fleeting cosmic privilege. Second, the cosmic tug of war. Third, chasing the stretching light. Fourth, horizons past versus future. And finally, number 5, the end of cosmology. So, part 1, a fleeting cosmic privilege, living in a temporary window. To really grasp why the universe is disappearing, we kind of have to understand the philosophical stakes here. Imagine if humans, or, any intelligent observers, had evolved billions of years later than we did. Our night sky would be largely empty. That vast, beautiful web of galaxies we see today just wouldn't be there. Observers in the distant future will look up and see a lonely island of stars surrounded by a totally vast, endless void. The brilliant cosmic evidence that let us discover the Big Bang, it simply won't exist for them. We are just so incredibly lucky to be looking up right now. Moving into part 2. The cosmic tug of war, gravity versus expansion. The actual mechanics of this cosmic erasure really come down to this massive ongoing tug of war. So on one side, you have the inward pull of gravity, right? And on the other, you have the outward stretch of space. Now, inside our local galaxy clusters, gravity wins. That's exactly why our Milky Way and the Andromeda Galaxy are actually pulling together and will eventually collide. Though, don't cancel your weekend plans or anything. We've got a few billion years before that happens. But across the massive intergalactic voids, the outward stretch of space is absolutely winning. The gaps between distant galaxy clusters are just growing wider and wider with every single second. And the driver of this relentless outward stretch is something we call dark energy. Now, let's clear up a massive misconception really quick. We need to explicitly debunk the vacuum myth. The universe is not some giant vacuum cleaner sucking galaxies away into the dark. Instead, it's better to think of space like a giant rubber sheet. As dark energy drives the accelerated expansion of the universe, that rubber sheet itself is stretching. The galaxies are really just markings on that sheet. They aren't moving through the space to get away from us. The actual space between us and them is just multiplying. Which brings us to part 3, chasing the stretching light, a photons upstream battle. So what exactly happens to light trying to cross that expanding rubber sheet? Well, it all comes down to recession velocity. Basically, this is the speed at which distant objects appear to move away from us. Because of the accelerating expansion of space we just talked about, the recession velocity of distant galaxies can actually exceed the speed of light. Now, hold on, this doesn't violate Einstein's rules of relativity. Nothing is moving through space faster than light. It's simply that the space itself is expanding so rapidly that the total distance is growing way faster than light can actually cross it. Picture it like this. A photon of light is emitted from a distant galaxy, and it's aiming straight for Earth's telescopes. But as it travels, the space it just crossed and the space ahead of it literally stretches out. It's like the photon is swimming upstream against this rapidly flowing river of expanding space. And if the space expands fast enough, if the recession velocity is too great, the photon is eventually just overtaken by the expansion. It just keeps losing ground and it never, ever arrives. Let's jump to part 4, horizons, past versus future and the limits of the cosmos. This whole upstream battle creates some very absolute limits on what we can interact with. First up, we have the particle horizon. This is a boundary of our observable universe, and right now it sits at roughly 46 billion light-years away. This is essentially our ultimate window into the past. It represents the maximum distance from which light has had time to reach us since the Big Bang, 13.8 billion years ago. We can actually see ancient light from galaxies near this horizon, even though those same galaxies are currently receding from us at speeds that far exceed the speed of light. So the crucial point here is that this is entirely different from the cosmic event horizon. The cosmic event horizon is actually much closer to us, currently estimated to be around 16 to 18 billion light years away, and this is the strict theoretical limit on our future interactions. Basically, if a galaxy sits beyond this line, any light it emits now, today, at this exact moment in time, will absolutely never reach us. It's caught in that upstream river of expanding space we talked about, and the current is just way too strong.
Let's look at them side by side because it really helps cement this idea. The particle horizon is our past limit, right? It's what we can physically see today based on ancient light. But the cosmic event horizon is our future limit. It's what we could theoretically reach or send a signal to today. Because the event horizon is shrinking relative to the expanding universe, a galaxy we can clearly see right now using its ancient light might have actually already crossed our event horizon, which means we're essentially looking at a ghost. We could never travel to it, we could never send a message to it. Functionally, it is already gone.
Now, as the universe ages, our visible region, that particle horizon, technically does grow because light just has more time to reach us. But the overall universe, driven by dark energy, is expanding even faster. So what's the result? We're actually seeing a smaller and smaller fraction of what is out there. Distant galaxies are continually slipping past our event horizon, completely out of our range of view, while our nearby galaxies are getting pulled tighter together by gravity. And this brings us to part 5, the end of cosmology, the apocalypse of knowledge.
This perfectly illustrates the deep future of the cosmos, an era that scientists rather dramatically refer to as the apocalypse of knowledge. Today, we have these 3 prominent pillars of evidence for the Big Bang. We can clearly see distant galaxies receding, we can detect the cosmic microwave background radiation, and we can measure the primordial chemical mix of hydrogen and helium. But billions of years from now, as our local group merges into this one isolated supergalaxy, every single other galaxy will have been driven past the event horizon. There will literally be no receding galaxies left to observe. The evidence of expansion will just be physically gone.
The night sky is quite literally going to fade to black. The cosmic microwave background, which is the afterglow of the Big Bang itself, will stretch out as space expands. Its wavelengths will lengthen from microwaves into radio waves, diluting until it is completely 100% undetectable. On top of that, multiple generations of stars will contaminate the original chemical mix of the universe. Just imagine being a future astronomer. You'd look up and have absolutely zero data to tell you the Big Bang ever even happened. To them, the universe is going to look static, eternal, and completely empty beyond their own supergalaxy. Let's walk through this grim but honestly totally fascinating cosmic timeline. So today, at 13.7 billion years, we are squarely in the golden era of observation. Fast forward to around 20 billion years, and gravity wins locally, meaning the Milky Way and Andromeda collide. Skip ahead to 100 billion years, and the expansion of space wins universally. All other galaxies will have redshifted into complete invisibility. And by the time we hit 1 trillion years, the primordial isotopes are lost entirely. The universe will have successfully and systematically erased its own history. Which leaves us with this final, really provocative thought. We know that the universe is actively erasing its own history right now. We know future civilizations aren't going to be able to see what we see today. But think about this for a second. What if it's already happened? What incredible cosmic secrets, what massive structures, what fundamental truths might the universe have already erased from the sky before human eyes ever even evolved to look up? Really makes you wonder, doesn't it? Keep looking up while we still can. Thanks for joining me on this explainer.